Power factor. What is power factor? Well, put simply, power factor is the measure of how effective power is used in a circuit. This is a formula for power factor, where F subscript P is the power factor which has no units, and theta is the phase difference between the voltage and current waveforms, measured in degrees or radians. So straight away we can see that the power factor will vary anywhere between -1 and +1, because it is described as a cosine function. If a circuit has a power factor of 1, which we call unity, then that circuit is 100% efficient, whereas if a circuit has a power factor of 0, it has 0% efficiency. When we talk about power factor, we always have to mention if it is leading or lagging. First off, power factor always follows the current. So looking at the diagram, we can see that wave A leads wave B. So if we let current equal wave A, then we would have a leading power factor. Whereas if we let current equal wave B, we would have a lagging power factor, the resistor. We can see here that for a resistor, the voltage and current are in phase, and therefore the phase difference theta equals 0. This gives us a power factor of 1, which is neither leading or lagging. Whereas for a capacitor, the voltage and current are out of phase, and they're out of phase by 90 degrees. You can also see that the current is leading the voltage. So plugging in theta equals 90 degrees, we find that capacitors have a leading power factor of 0. Inductors are similar, as voltage and current are also out of phase by 90 degrees. But instead here, the current is lagging the voltage. This results in inductors having a lagging power factor of 0. Putting it all together, for a circuit made up of resistors, capacitors, and inductors, the phase angle will range anywhere between 0 to 180 degrees, and therefore the power factor will range anywhere between -1 to +1. Let's have a quick look at an example. So here we've been asked to find the power factor and state whether it is leading or lagging, and we've been given the voltage and current waveforms. So the first thing we need to calculate is the phase difference, which we find by taking the absolute value of the difference of the phase shift of the voltage and current waveform. When we do that, we find that our phase difference is equal to 50 degrees. And we plug our phase difference straight into the power factor formula and find that our power factor equals 0.643. Now we just have to figure out if our power factor is leading or lagging. And we do so by drawing a diagram of our voltage and current. And when we do that, we find that our current is lagging the voltage. So therefore, our power factor is lagging. Putting this all together, we find that our power factor is equal to 0.643 lagging. Thanks for listening.